streaming.
town hall meetings.
Oh, that was crazy. Almost. Mitch was in the Matrix for a second.
There's a lot of videos out there that show you how to perform IP.
Seriously, Mitch, you didn't get the Bluetooth paired?
I did. It's right there, the ISB. ISB's nuts.
But it usually involves some type of math. You have to understand the powers of 2. You need to understand how to convert from decimal to binary and back to decimal again. And one of the challenges that you're going to have when you sit down for a certification exam is you may not have the time needed to be able to perform all of those mathematical calculations. You also have to keep in mind that you're sitting down for an exam, and that process can be rather stressful. It's difficult to be able to calculate these things on the fly as the clock is ticking. So I wanted to put together this video that showed the process that I use during a certification exam to be able to subnet very, very quickly without having to go through all of those mathematical processes. Well, there's a little bit of math involved. You do have to be able to use some simple addition to create some tables prior to sitting down and starting the exam. And when you perform the actual subnetting, you have to be able to subtract 1 and add 1. And during an exam, I don't think that kind of math is something we need to worry too much about. This is really a combination of a lot of different processes. I wanted to create a series of subnetting processes that got rid of the math and tried to make the process as simple as possible, removing all opportunities for you to make a mistake during an exam. Now, if you're already familiar with subnetting, some of these processes may be oversimplified, and that's fine. You can skip over the things that you already know. But if you're like me and that stressful test situation is one where it's very difficult to concentrate, then this 7-second subnetting process is going to be for you. Here's a common subnetting problem you might be faced with on an exam. You're given a network configuration. In this case, we have 4 separate networks. You're given an IP address assignment, 192.168.1.0, with a /24 subnet mask. It says that we need an IP addressing scheme with more than one network address that can support 40 devices per subnet. So we've been given the single network address. We need to subnet it out into at least 4 networks, and those 4 networks need to at least have 40 devices per subnet that can be supported with that IP addressing scheme. If we wanted to write this out in a longer form, we could of course write down all of the different subnet mask options. We could convert those to binary so we can use those for calculations later. We might want to reference that back to the CIDR block notation, and we'd be able to see how many networks and how many hosts per network would be for each individual subnet mask. Obviously, on an exam, you don't have this kind of time to write out one of these extensive charts to be able to start calculating a subnet configuration. To do this a little bit faster, we might want to use the power of 2s. We can, of course, create a power of 2 chart or memorize these powers of 2. And then we would look at our subnet mask. We know it's a /24, so we have 24 bits that are already masked. So we might want to borrow some bits from the ones that are left over. We might want to borrow 2 bits for a subnet mask, and then use 6 host bits to use on top of that. Now we know that with those 2 bits that we're borrowing, those subnet bits we would calculate as 2 to the 2nd power, since we're borrowing 2 bits there, and that would give us a value of 4. So the total number of subnets would be 4. We've got 6 host bits, so it would be 2 to the 6th power, and calculating that out would be a 64. And of course, we subtract 2 from that to subtract the broadcast address and the network address. That leaves us with 62 as the number of hosts per subnet. And there's the answer we were looking for. We now have 4 subnets, and we have 62 possible hosts per subnet, all because we were able to remember that powers of 2. But of course, even this process requires that you do a little bit of work. You need to convert things to binary. You need to figure out how many bits you're going to borrow. You need to calculate this based on the powers of 2. And you either have to have a table already prepared, or you need to remember those powers of 2 so that you can use them very, very quickly on an exam. Remember that when you're subnetting, you're really looking for 4 different addresses. The first one is going to be your network address. Some people call this the subnet address, and it's the very first address that is in a particular subnet. We also want to find the broadcast address. That is the last address in the subnet, and it's the one that is used when a broadcast is sent on an IP version 4 network. We also need to know the first available host address on the network. This will be the one that our workstations and devices will use on that network. And obviously, we then need to know what the last available host address will be for that network so that we can determine the exact range to use for all of our devices. Well, if we take our previous example, you can then see that we would have to write out all of these in binary. We would have to determine the different subnets by changing the binary from 00 to 01 to 10 and then 11, and then calculate all of the first host and last host addresses by comparing the differences in the binary settings for all of these different addresses. Obviously, on an exam, you don't have time to go through this entire process to create all of this information. That's why I created the 7-second subnetting process so that we could very quickly determine all of these in just a matter of seconds and then continue on with what we needed to do for the exam. If you've looked at other subnetting videos or you performed some subnetting yourself, you'll notice there are certain patterns in the math. For example, a 255.255.255.0 subnet mask, it's a single subnet and it's a range between 0 and 255. If we grab one extra bit off the end and make it 255.255.255.128, it effectively cuts that in half. So we have a range between 0 and 127 and another range between 128 and 255. If we borrow another bit and make it a .192 at the end, you'll notice we cut it up again into smaller pieces. We're separating these in half every single time. So now we have a process that we can easily see is occurring every single time, and we are going to be able to take advantage of this very common theme whenever we're trying to subnet. We're going to create some tables, and from those tables, we'll be able to calculate exactly what the subnet might be without having to go through any of the binary math. We're going to make two charts to help with this subnetting process. The first chart is going to be one that will help us convert from a CIDR block notation to a dotted decimal notation. This is especially helpful when you're given one of these questions that will require you to convert, and having this chart available will allow you to do that very quickly. The way I like to lay this out is to make 4 separate columns, and each one is associated with one of the octets of the IP version 4 IP address. I put a /1 through /8 in the first column, /9 through /16 in the second, /17 through /24, and /25 through /32 in the fourth column. Then I want to calculate how many networks will be available in each one of these, and I put a 2 on the first row, and then I multiply that by 2 each time. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, until I get to the bottom, and the last number should be 256. Then I create an addresses column, and I usually start at the bottom with the number 1, and again I'm doubling each time. I double to 2, 2 times 2 is 4, 4 times 2 is 8, until I get to 128 addresses. And now the final column, which is going to help me make that conversion between the CIDR block notation and the decimal notation. I'll start with 128 at the top, and then I'll add in 64. So I'm effectively adding as I go down the addresses column. 128 plus 64 is 192. 192 plus 32 is 224. 224 plus 16 is 240, until you get to the bottom with 255. The second chart I create is one that shows me the address groupings given a particular subnet mask. If the subnet mask has 128 as that subnet mask, then I know that the subnet will be split into 2. There will be a starting number of 0 and a starting number of 128. If it's a 64 as the number of hosts in a subnet, then I know that my subnet boundaries will be 0, 64, 128, and 192. And I write all of these out. It's obviously pretty easy to memorize an address boundary at 128 addresses or 64 addresses or 32. But when you get into these smaller numbers, especially as it gets higher up in the list, it becomes a lot more difficult to remember where the exact boundary is. And remember, we're trying to do this as quickly as possible. We don't have time to calculate all of these on the fly, so I write everything out during this period so that it's now sitting right in front of me and I can perform any type of subnetting now in 7 seconds. Of course, all of these charts are the ones that work for me. You may find a different layout or a different way of performing this might work a little bit better. The key for me is to get everything on the page. That way I don't have to perform any of these calculations during the exam itself. Now that we have our charts available, we're able to subnet. The things that we're going to be able to derive from these two charts is that we're going to be able to convert the IP address and a CIDR block notation into the decimal form. That first chart that we created allows us to do this very quickly. That chart is also going to show us how many devices per subnet will be on this particular network. The second step of the subnetting phase is to calculate the network address. Some people call this the subnet address. And that second chart that we created allows us to very quickly find the beginning and the end of that particular subnet. Thirdly, we need to know the broadcast address. This will be the last address. And again, that second chart shows us what the ending boundary is. And lastly, we need to calculate the first usable and the last usable IP address of the subnet. That's very easily done by simply adding 1 to the network address and subtracting 1 from the broadcast address. Let's try doing a few of these and see if we can get the hang of it. The first subnetting that we're going to do is address 165.245.12.88 with a /24 subnet mask. Generally, the subnet masks that end on the 8-bit boundaries, the /8, the /16, and the /24, are generally something that's easy to calculate. But let's go through this process to show you how it would flow, and then we'll try some harder subnet masks after this. The first thing we need to do is convert both the IP address and the subnet mask into a decimal format. The IP address is already in decimal format, but this /24 needs to be converted. If we look at our first chart, we need to find the /24. It's in this third column. That's important for later. And you'll see that it converts to a 255. So let's write these down. We've got our IP address at 165.245.12.88. And my subnet mask has a 255 all the way into the third column. So we're going to use 255s all the way up until we hit that third column. And since we are in that third column, everything after that point will have zeros as the subnet mask. I'll show you in a later example how this changes if the mask is not a 255 or a 0. Now that we have both our address and our mask, we need to calculate the network address. If the mask is 255, you bring down the address value at the top, and if the mask is 0, you simply use a 0 in for the network address. That means that if we bring down the 165, the 245, and the 12, and then bring down a 0 where the mask is 0, our network address 165.245.12.0. Now we need to calculate the broadcast address. For the broadcast address, if the mask is 255, we bring down the address number, exactly the same process as if we were calculating the subnet address. But if the mask is 0, we make that value a 255 instead of a 0. So that means our broadcast address is 165.245.12.255. Now the process of determining the first usable IP address and the last usable IP address is simply adding a 1 and subtracting a 1. So the first usable IP is the network address plus 1. So it's 165.245.12 plus 1 to that 0 is a 1. And the last IP is a broadcast address minus 1, which means it's 165.245.12.254. And you can see they're listed there. So for this example, you can see what the network broadcast first IP and last IP addresses would be for this particular IP address and subnet mask. Now let's try a subnetting problem that's a little more difficult. This one falls into the 4th octet. It's the same IP address, 165.245.12.88, but on this network, this particular device is on a subnet /26. Let's perform exactly the same process and see how quickly we can calculate the results. The first step is to convert the IP address and the mask to a decimal. We know we have the IP address of 165.245.12.88, but we've got this /26. So we need to use our first chart to find the /26. You can see that the /26 is in this 4th column. That means that whatever value we find here, which happens to be 192, is what we're going to put into the 4th column of our subnet mask. Everything prior to this number will be 255s, and if there were open octets after this, those octets would be 0. So for our subnet mask, since this is in the 4th octet, it's 255, 255, 255, 192 is that conversion for the /26. Another thing to notice as we're determining what this subnet mask is, it was a /26 that converted to a decimal 192, but notice that the number of addresses is listed as 64. That means we need to go down to our other chart where we have listed out all the addresses as 64 and determine where that number happens to sit on that particular column. That column was the 4th column. That was the one that was different than a 255 or a 0, and an 88 is the number in the address. So we need to find in this particular row where an 88 would fall. And in this particular case, it falls into this range that begins with a 64. That will be very helpful when we start determining where the beginning of the subnet is and where the end of the subnet is. So let's do that. Let's calculate the network address. If the mask is 255, we bring down the address value into a column. If the mask is 0, we'll use a 0. We don't have any zeros in our mask in this example. For any other number, we refer to the chart. And again, we had a 192 there, so we need to refer to our chart on that 64 row and determine where the 88 sits, and we know that that particular range starts at a 64. So our network address is going to be 165.245.12.64. Our next step is to find the broadcast address, and we've already done the work up to this point. We really don't even have to calculate anything because we know exactly where in this chart this particular range is for this subnet. We know that the network address is 64, so at the other end of this range is the number 127. We know it's 127 because the next range or the next subnet starts at 128. So very easily we can then bring down 165.245.12.127 and we have our broadcast address. And just like our previous example, to find the first usable IP address and the last usable IP address, we add 1 to the network address and we subtract 1 from the broadcast address. That means that the first IP will be 165.245.12.65 and the last usable IP will be 165.245.12.126. And there's the answer for the subnet 165.245.12.88/26. Let's run through another example. We use exactly the same IP address, but notice the subnet mask is different again, 165.245.12.88. This particular IP address is on a subnet /20. Same process that we used before. We need to convert that /20 to a decimal. So we're going to bring down the address value. We're going to find the /20 in our chart. And when we find that row, we'll see that it's associated with 240. But you'll notice that the /20 is in the third column of our chart. That means that the 240 is going to fall into the third column of the subnet mask. Everything before that value is 255. Everything after that value is a 0. We also know from our chart that there are 16 addresses in this subnet. So if we look at our row where all of the 16 delineations are, we need to find that number for that third column. Everything focuses on the column where that value is a little bit different. So that 12 that is in the address needs to be put into this row where there's all the 16s. Now 12 is certainly between 0 and 15. So it's in that first section of that particular row. So we know now what the exact range is going to be for the network address and for the broadcast address by very quickly determining where it happens to sit. So we want to be able to bring down any of the network addresses where the mask is 255. If the mask is 0, we use a 0. But for that column that has that 12, we know that it's actually going to start this range at 0. So our network address is going to be 165.245.0.0. The broadcast address works exactly the same way as the other examples as well. If there's a 255, we bring down the address. If there's a 0, we bring down a 255. But again, we've got this third column, so we need to look to see what our range is for this column. And because it is the 16s, we know that it goes from a 0 to a 15. So we can look at our chart and know immediately it's 165.245.15.255 is our broadcast address. From here, of course, to calculate the first usable IP and the last usable IP, we're simply adding 1 and subtracting 1, which makes our first IP 165.245.0.1. And the last IP is 165.245.15.254. You can start to see how fast you may be able to make this work once you become accustomed to knowing where to look in the charts and where to find the information that you're looking for. Let's try one last example. Let's try and address 18.172.200.77/11. It's the same process we used before. We're going to convert that /11 to a decimal. So we need to find the 11 in our chart. It's in the second column. You can see the /11 is a 224 with 32 addresses per subnet. So if we write this in, it's 255.224. Again, we put it in the second column because that's where we found the /11. Everything prior to that column is 255. Everything after that column is a 0. Now that we have the address and the subnet mask written in decimal, let's find the network address. We know that we're going to be using these 32 addresses per subnet. We're going to look at our row where the 32 is, and we're going to look at our second column, since that's where we found the /11. The address value is 172, so we need to find in our row where the 172 happens to be. And it's in this range right here between 160 and before the next subnet starts at 192. So it'll be 160 through 191. Well, now we already have the values we need to calculate the network address and the broadcast address. So we'll use those numbers with the 160. We'll bring down the 18, we'll use the 160, and of course where there's a 0, we bring down the 0 for the network address. For the subnet address, we use the last value that's in this range, which is a 191. So it would be 18.191, and of course where there are zeros, we bring down the 255, and that's our broadcast address. And for the last step, where we want to find the first usable IP address and the last usable IP address, we'll add 1 to the network address and subtract 1 from the broadcast address. That makes our first usable IP 18.160.0.1, and our last IP is 18.191.255.254. And there's the answer for the IP address subnetting for this IP address of 18.172.200.77/11. Now that you understand the process that I use to understand this during an exam, you can of course try this yourself. Write down your own charts, customize them to fit best for the way that you work, and try some IP address problems yourself. You may find that you're able to perform these very quickly in a very short period of time, and it's certainly a good way to check your work when you're in the middle of an exam.
I don't know where Mitch is at, but you know he's doing a great job of doing what he's supposed to do. Okay, what'd you guys think about that? That was grand,
It was
wasn't
a
it?
bit fast. I'm gonna have to rewatch the video. So that's
7 seconds.
20-minute video. It says 7 seconds. I mean,
Yeah.
is that?
I guess I'm up. Thank you. Wow. Mr. Branham?
That was pretty sweet.
That was. I do have to say you were. Hey, slacking on your job, dude.
What are you talking about?
It was time to
Troubleshooting networks. The best tools available are at the command line.
Projector go to sleep or something?
No, I just turned it off.
I was just playing the cat video that I wanted to play out there.
Freaking out. Okay, so the reason we chose, once again, the reason we chose subnetting was because, I mean, each and every one of us touch subnetting every day in some form or fashion. Knock, you're touching it when you're troubleshooting anything at a site. Implementation, you're touching it when you're deploying a site. So it's something that we all have to be kind of vigilant in as far as actually thinking. And one of my prime examples that I used yesterday was, I can't remember if it was Ogden, Gananda, or Farmington. I think actually it was 2 sites. So when we normally retrofit a site, what we like to do is we'll take, so if this is our existing equipment, say this is our existing equipment here. Well, typically we always have an internet, and we do 5 static IP addresses. And then we'll have a T1, or we'll put MPLS. So we have this connectivity here. So that's typically what a site looks like. We have an MPLS, we have a cable modem for failover stuff. What I like to do is when we're retrofitting, so Farmington, Ogden, and Gananda was a retrofit. They basically renewed contract with us. They maybe added service or whatever like that. So what we like to do, and as we move forward, we're starting to do more staging. As you see, Mitch is actually not doing the training class. He's actually wiring this up. We're staging equipment in here as much as we can. We're trying to get it configured. We're trying to get it tested, vetted. Working on, like, you know, as we get 819 chassis in here, we're going to pull management cards to make sure that the management piece fails over. we have a pretty extensive checklist that we're trying to put in place. So as we're deploying these sites, as we're configuring them here, we know it works before it leaves the door. And then Nick did we did a sign-off sheet. So for Lady Lake, which actually is arriving today, I think, on site, we had the zone chassis in here. We had them configured for internet. We have a test dummy phone that we're using right now for a line that Joe gave me. But we spun up all 3 zones. We're supposed to have 4, so I mean, we only had 3. We spun up all 3 zones, and we configured services for internet, telephone, and then I brought a line from our lab IPTV and just did a NAT translation and brought one of our set-top boxes in here. We plugged it in. We plugged it in each one of those zone chassis, and we did channel changes. We did phone calls, and we did internet, and it gets us all on the same page. I think David Curd had one time where it didn't refresh fast enough, but the modem came online. But my goal is to get as much of the site that we can in here, get it configured, confirm it's configured, confirm any failover pieces we can, then have everybody from each group, a group of people from each group, not team A, not team B, implementation, TS. We come in here, we all look at it. We're like, oh, hey, just maybe we might be able to identify a problem. If we see slow channel changing, or, we see something wrong with internet speeds, or, the more eyes we get on this, and my actual goal is we normally do the knock handoff after everything's been handed off. Before, sometimes knock would get involved with provisioning of some lines and stuff like that, but there wasn't really a true handoff until basically implementation was done with the job, and it was time for the knock to then said support it. Kind of want to change that mentality. I want it to be where we get we have our site plan. Here's our port assignments. Here's the equipment that's involved. Don and Mitch are going to be in here configuring equipment, doing the interconnects, making sure it's all connected right. They can see everything. We're starting to put those little PCs in there that we can do monitoring stuff as well. And I want to bring you guys in here before the equipment leaves site. That way you can get a visual. Okay, this is what's going down there. So like when you're on the phone with somebody, you're like, oh hey, I remember seeing this is what was in there. This is the equipment I saw. That way you guys know ahead of time. So when we do get it on site, we get the MDF racked. We can then say, okay, hey, we need you guys to make sure that you have connectivity to all the equipment down there. Just log in, look at it, see if there's anything that we're missing. Just kind of like a quality assurance that hey, connect to it. But anyways, what I was going with this is when we retro site, I always like to do, and this is my IP example. Before we did the project, sales engineering hits it, sales hits it. But when we did these sites, Ogden or Gananda, one of the two, it was one of the sites, they only had one static IP address from the cable modem provider. So when I went to spin up the new, guess what? Couldn't. Because they had residents accessing the internet from this single static IP address. We had, it just turned into, me remoting into Pat's machine. So little things like that. Making sure we have block 5 IP addresses. That should be I think that's our standard protocol now, but at some point it was missed. So that's my thought process is, we always like to have a block 5 here on the external. That's some of the things that you guys are going to have to run into. Like we do a lot of natting and port forwarding for different, different IP addresses. You're going to see that. With FortiGates, with virtual IP addresses, it's not like a NAT. It's virtual, but it's natted. But subnet. That's where we kind of lose track of things. I'm going to grab my laptop because I'm going to pull up the camera sheet. Another thing is I just want to make sure that you guys do understand. Like I've had this recently to where let's go over some basic subnets that every one of our sites use and we use every day. Let's start there. So this marker is sucky bad.
Here you go.
Here's one for you.
Yeah, I could use that one. Okay. So, there we go. That's what I'm talking about. 10.12.88.0/24. Not the guys in my group. Do you guys know what subnet that is? What subnet is that?
That's the subnet itself.
That's in this
that
building.
address.
That's your
Oh, I
guys.
see what
That's
you're
your guys' workstations. And anything on our network here locally. The reason I point that out is because there's been a misconception as far as like if we stage something in here with that IP address, that's not going to work on site anywhere. That's exclusive to here. That's it. I mean, okay. So.
Sorry, I misunderstood the
Oh, you're fine. Can anybody tell me where that subnet's at? 7610.211.0/24. I'll give you an example. 7610.211.30. You can't answer.
Sounds like a public IP, something that you would access a firewall,
Okay,
one of the firewalls. On something.
you're on the right track. So 7610.211.0, any of that /24 is our public in Columbus. Let's do, I'm going to name these for you guys. Esco,
I thought our public in Columbus was a 192 address.
that's a private bitch. So 7610.211.0/24, we own that entire /24 for our public in Columbus. So some of the things that you guys are going, that's going to relate to you guys is, I'll give you some of the IP addresses. 7610.211.30 is proxy2.esco.tech.net. That's proxy 2. So if you're ever troubleshooting an issue where you think that it needs to be failed over or something like that, here's one of the first things. Whenever somebody says that there's like a T1's not working or something's, they're having problems with connectivity, I'm going to tell you my troubleshooting steps right off the bat. I log in to the external of an AdTran or whatever like that, and I trace route. And I'll go over the rest of these. So, some things you're going to hit Columbus. You're going to hit 7610.211.30. 7610.211.65 is our SMTP relay server. Six 10.211.145 is our repository. And that's going to be one of our classes, our central repository for firmware images, backups, and things like that. So we'll move on to the next subnet just so I can explain my troubleshooting steps. I'll let Mitch answer this question. I know this seems really stupid, doesn't it? I mean, having a corporate infrastructure with a 192.168.0 dot private address. How many modems or how many homes are 192.168.0 dot address?
All of them.
Yes, most of them. Well, mine's not, but unfortunately, this is what we have inherited. Our Columbus core infrastructure, our internal IP addresses are 192.168.0 dot /24. We have great ambitions and dreams to change that, but Metaswitch lives on all of that. So there are some future plans to, and I'm really trying to do a push for this. Metaswitch actually has a Amazon Web Services deployment to where it's all in Amazon. It's all built in Amazon. I'm really trying to push to go to a cloud instance of Metaswitch. It is
Nice.
what it is. let's go, let's see if anyone. Does anybody know what this IP address is? Or that subnet? Go ahead, Brandon Mansor.
CBG.
That is CBG's public. So some of the addresses, this address right here, 64.245.205.30, that's where every single phone in this organization is registered to. That is proxy 1. That lives in CBG. And then finally, we have 192.168.20.0/24, which is CBG private. They were actually smart with this one. They went with a different third octet for the 192 network. There's a million other subnets that we have in Columbus and Cincinnati. The IPTV stuff is completely separate from all of that. We do have uplinks for our IPTV stuff with the public and our public and our private. We do have IPTV stuff that resides on that. That's only for voice integration.
That's over at P10 on the house.
I'll draw that out too. I'll kind of explain our infrastructure as well. So, say you have a site that's down, or you say that they're saying they're having voice troubles or whatever it may be. Your primary concern when it comes to that are these 4 IP addresses. That's what you got to worry about. Primarily, it's the 64.245.205.30. That is proxy 1. Like I said, every phone in this organization is registered to proxy 1. I don't know why. That's just the way it's set up. This is proxy 2. There may be some stragglers that I know we've done some testing with it. And then these the .40 IP addresses are call feature servers, CFSs, and that's more pertaining towards business phones. That's what does all the voice caller ID, but the on hold stuff like that. It does the more of the business features. So whenever you guys have an issue to where you say, okay, we're having troubles with voice, we're having troubles with this, I always trace route to see where is it going to, how is it getting to the core, is it making it to the core. So I always do trace routes to make sure, okay, what's actually happening from the site to our core. And I'm going to give you a perfect example. If it's going out always pay attention to your VLAN and then your either 1 or 101. Pay attention to the 172 if it's 17 or 18. Pay attention to it, or 16, 17, or 18. Pay attention to that, because if your first hop for any of these sites is the 172 network, that means it's trying to go across something internally. Now, if it is hitting a 192.168.21 through 4? Yeah, 22. Did we do 22?
They go to 22.
21 or 22. If your first hop from that AdTran or that FortiGate that you're trying to make sure that you have connectivity to the core, to our data centers, if it hits a 172 address, that means it's trying to reverse either an IPVPN or an MPLS. Simple as that. If it's trying to hit a 192.168.21 or .22, they should all be changed within the next, couple weeks. We have some stragglers out there that were. So basically, we're trying to change all of our tunnels from the cable modems to the 21 or 22 to make it a lot easier. It collides with our IPTV network, some of the IP addresses, and it makes your guys' jobs easier, because then at that point you can say, well, my first hop is a 172, so it's trying to go down to MPLS or an IPVPN. If it's going out of 192.168.21 or .22, it's trying to go across the core. It's trying to go across the tunnel, rather than that means the T1's down, or there's something wrong with routing, or there's an interface down, or something like that. So we're trying to simplify that process. So what I always do, I do my trace route. I see which direction it's going. Say it's going this direction, and it just dies. It craps out. That typically means whatever if you're going across an IPv, like in Canterbury's case, that's an IP VPN. In Seabury's case, it's an MPLS. If it dies after this hop, that means your T1's down. That's great. So you put in a ticket, and then we'll go over the failover process for that. That will be another training class. There's actually in the ad trains, there's a thing, it's called a track. So it tracks. And if it's showing a track that's still up and you shut it, it will fail it over to this. So, I mean, that would be a whole other training process. But say it's not hitting the 172 network and it is going out to 192.168.21 network, but you still have connectivity issues. They're still showing registrations down. My next step is I take these same IP addresses and I ping them. So you can ping all of them, but you're still showing voice. You're not passing voice. You're not able to, get registrations up. At that point, it becomes a core problem. That's when you guys would hand it over to us. That means there's something wrong with the failover route in the core, and unfortunately, that's all us. That's nothing that you guys can do. So, so in that case, that's just one of the instances where I start to think of IP subnetting and net mask is that knowing our basic generic IP subnets that we use for communication in our cores and on sites will help you guys tremendously in troubleshooting. Because like I said, if you guys put in tickets, say voice registrations are down, not passing traffic, this is exactly what I do. I trace route it, I see which way it's going. If I see it die at the MPLS, I'm like, okay, let's fail the track over. If I see it going out here, but we still don't see registrations, then I hop into the core and I find out what's going on with that route. It's as simple as that. Does anybody have any questions about our subnets and anything that I just talked about?
Ours is shut a little.
No, thanks.
In the coming future, is that how it's going to be from here on out, or in like a couple of months, 6 months to a year? Is this information going to change, or
No.
no, not even for the .0.0
No, I mean, I don't see that project happening.
Right.
I'm talking like,
forever?
I mean, in order, to be honest with you, to be 100% honest with you, where we're at with our MetaSwitch stuff is we're going to do a few of the upgrades on like the SaaS stuff so we can keep longer SaaS traces and things like that. But I mean, to do that MetaSwitch cloud, I mean, that's going to be a major, I mean, I think that would be like a year deployment. I mean, before we would even think about moving customers over to it. I mean, I think that it's that big of a deal. So yeah, for the most foreseeable future, none of these subnets are going to change. This one, I mean, I know you guys don't really troubleshoot this one. This is going to change for other people but you guys. I'm a huge fan of segmentation. And the reason I like segmentation is because it separates, it makes it easier to secure things. Jennifer and the accounting group, they don't need access to our sites. Jerry and Kristen, salespeople, Tech Connect, they don't need access to our sites. They don't need access to our cores. They don't need access to any of them. So my plan is to eventually migrate them to their own subnets, have them separated, and then my overall eventual goal is to make so like where our drives are, our domain controllers, SQL, all of everything that we have here hosted locally, I want to move that to its own subnet. And then I can control the access rules between different subnets and our servers.
Well, managing all that at the core, pretty much.
Mhm.
Nice. Okay.
So I'd like to get to the
every
point.
department essentially be on its own subnet.
Yes.
Okay.
So basically, like right now, I do have a subnet set up because I wanted to do it immediately, so it was like a rush thing. I have a subnet set up for Tech Connect and sales right now. They're on a 10.12.86.0/23. The reason I did that is because some of those laptops we don't own. They're 1099s, so they bring their own laptops in here. I had one guy that was just doing network scans of our network, and I caught it, and I'm like, okay, no more. mean, I don't own that piece of equipment, and I told him to stop doing the scans, but it's not my equipment. I'm not going to just sit there and wait to watch, him do network scans, and slap them. So I'm like, okay, I'm gonna separate them. I'll give them access to what they need access to. So they have access to their shared drive. They have access to the internet, all that stuff. But I'm a huge fan of segmentation. I do it. I mean, we'll go over the Canterbury layout and explain that a little bit because Canterbury is it's not one of our biggest customers, but it's one of the biggest networks that we actually manage and maintain. Just due to the fact of,
I had a question on the 10.12s. I see now that immediately rings IPTV when I see that. Because that's every single IP
because
for TV. Are we routing that from our core?
No.
Okay.
So that's a good point. Our standalone IPTV sites, they do have a 10.12. They actually have two 10.12s on that. They have. That black one's horrible. So our standalone IPTV sites, and I can't think of it off the top of my head. I think it's a /21. This is.
That's right.
I thought it was.
They're both /24.
I thought it was. So Seabury, Wesley Wood or Wesley Towers. I'm really drawing a blank on most of our IPTV sites. Bethany, I can't even think. I didn't think about Bethany, but Bethany actually that's a little bit different of a beast with voice. Every one of these IPTV sites that have like their own server sitting on site, smart boxes and things like that. Their IPTV is 10.12.0/21. That's not routed outside of there, so it's all self-contained within their site. Their residential internet is 10.12.8.0/21. That none of the residential stuff comes back to our core at all. So you'll see that that's pretty much standard right there. The only thing that's routable back to our core, other than the management and the voice, is now the IPTV2 sites. So Farmington, Ogden, Gananda, Kalamazoo, Lady Lake, and Canterbury. Their video VLAN, they all have a different subnet. So I think Lady Lakes was 10.0.48.0/21. That's going to be their IPTV subnet. And the reason being is, and I did this for the last group of people too, I might as well do it too. Everybody, you guys all understand the BCC, right?
Yeah.
You guys understand that? Nick, do you understand about how it works and
I
the
didn't.
BCC and stuff like that?
Broadband.
It's when you don't want somebody to see you copy them on an email.
Honestly, I don't know.
What a jerk!
I don't know BCC.
Okay, I'm going to explain it to you a little bit. And
I guessed that was not what he was
You hurt
talking about.
Brandon's
But
feelings.
Yeah, you really did.
no, I hurt his feelings when I tickled his ear when I walked by.
Well, that did too.
I'm just going to give you guys a word of advice. Brandon does not like to be touched.
Yeah, if you touch him, he might suplex you.
Yeah, he might go all incredible bulk on you. And so I'm going to do the same thing I did.
Todd's still shocked.
Todd's still in shock and awe about Brandon going Hulk on him.
I didn't go home.
That's not what I heard.
That's not what I heard. That's not what I heard. Okay, so
Rumor on the street.
I'm gonna break down Canterbury for you, just because they are a site that utilizes the BCC and they're one of our largest network sites. So Canterbury has 9 or actually they have 12 subnets out there.
Okay.
12 VLANs. So we have 100, 101, 102, 103, 104, 105, 106. Did I skip one in there? Nope. 107, 108, 109, 110. Gee, what you left? Okay. So, and I'm going to put what they're used for as well. And you're going to see this quite frequently.
I noticed troubleshooting Bethany this morning that they were on completely different VLANs then. They were
Well,
like
Okay, I haven't given you the full disclosure on Bethany as well. That's a whole different beast. Bethany's double natted. We have a 48 up there just running residential internet, and we nat the traffic from the 48 to the ad train
Oh,
for the
that's the one where
public.
you got to add max and probably a train.
I have a VLAN question.
That's
Yes.
nasty.
I mean, I understand. I thought VLANs were just a certain subnet. I guess that's more segmentation. So,
Yeah,
what does the
so,
VLAN number exactly mean? What does that correspond?
That's just an identification number.
Okay.
So the VLAN number is actually just so you have, when it comes to VLANs, you have 1 through 4093. There's 4,093 available VLANs on every layer 2 switch.
Okay.
And before, our standard practice was we used 1 for Esco data, 2 for voice, 3 for video, 4 for residential. Well, our problem with that being is a lot of our vendors, for their management interfaces, stuff like that, they use the standard VLANs, 1, 2, 3, 4, and we started seeing conflict with that. So we posed the question is, why don't we just move it to the 100s, and then we're kind of safe there. Nobody uses them, like our DIA high handoffs from level 3, nobody uses the 100s. They all use 3,000, like 3598 and crazy stuff like that. And I'll start putting segments on here.
And for the network management stuff, is that like the open source and stuff like
That's
or the
that
open
is
gear and
that is strictly for their network. I'm going to explain each one
okay,
of
I'm sorry.
these VLANs, and you can kind of get a glimpse into my head that
Okay.
why I did the things that I did. Man, that's way too much.
Wireless and gas.
Totally segregated.
But usually, in a typical Esco network, you'd have it all that on 104. Or wireless and gas, right?
No. Absolutely not. I do not want guests residing on the same
Anything.
as any business network. Segmentation, Mitch. Segmentation.
And the only reason it's like this is because they have a business.
Yeah, but as in the foreseeable future, we have a lot of this coming down the pike. Okay. The reason this network's so huge is because multiple reasons. When I first talked to Drew, they kind of just had one big one big mesh of a network. So you could connect to the Canterbury Court Wi-Fi, and you could see all their security stuff, you could see all their workstations, you could see all their servers, you could see everything. Everything that they had on that network was just on one SSID. And when I had talked to him, we kind of wanted this segmented, and he wanted a little bit more security, and he wanted to be able to kind of decipher what was what, because he really had, you know, a very few insight of who was residing on what. So we did this 192. We did this network management, and the network management at Canterbury is really a dual function. They have the ability to log into the switches as read only, so they can log into the switches and look to see what's there, what's plugged in. They can do a show MAC address. They can look at the descriptions that we have labeled in the switches. Basically, it's really to appease, you know, let them feel like they have some insight on their network. In addition to their network management aspect, they also have their servers that reside on there. They have 2 VMware hosts, and then they have roughly about 6 guests. They have a domain controller, they have a Great Plains controller, or a Great Plains server, which is their accounting application. They have some security stuff, but mostly it's just data shares and things like that. So Esco data. Esco data, you guys all understand that is our management. That's all that is for. Esco data is our management. That's there for us to get in and manage the equipment that's on site. So everything should have a VLAN 101 IP address. Esco voice. So let me take a step back. Let me go back to the Esco data. This is where the BCC comes into play. So we have all this equipment on site at Canterbury. We have redundant FortiGates. We have our layer 2 switches that have the redundancy between them. We don't pass out any IP addresses for this VLAN and this VLAN. Reason being is because we have AIR's cable modems down there. And what happens is we have relays put in our FortiGates that says, I'm going to send all my DHCP requests for AIR's cable modems out to the BCC. Okay. And what it does is that FortiGate will forward those packet requests for the DHCP to the BCC. So what needs to be there in order for that to happen? One, you have to have a route to the BCC. The BCC has to be able to see the FortiGate. So whether you're like Canterbury's on the IP VPN, but if that IP VPN goes out, guess what? You're not going to grab. If you reboot a cable modem, you're not going to have an IP address unless the failover is in place across the cable modem. So basically, what happens is an AIR's cable modem will come on and it hits the FortiGate and says, "Where's my IP?" And the FortiGate says, "I don't. It's not my job. I'm going to forward you onto the BCC." It goes out to the BCC and it grabs an IP address. Once it grabs that IP address, it actually checks in with the TFTP server and grabs its config. So it grabs a file from the BCC and says, okay, here's my properties. This is what I'm supposed to do. So like a couple weeks ago, Tim put in a new client class for the newer speeds. So we did 25 by 5. So those modems, when they check in, they're like, okay, I have a new configuration file. Boom. My new job is to allow everything behind me to do 25 by 5. So that's where the BCC comes into play. It's called Broadband Control Center, and it does that check-in. So here's the next caveat of it too. Our VLAN 102, which is for voice. Now this isn't in the future. I'm considering on separating business voice and residential voice. Mm-hmm. That's just an idea I've got in my head, but I don't know as far as our growth pattern. If we're going to have enough subnets, if we're going to, it's a battle internally and inside my, yeah. I would love to have business voice and residential voice separate, but then I start thinking about all the usable IP address schemes that we have, and that would kind of put a damper on us. But so even at Canterbury, I don't care if it's an AIR's cable modem or a Yalink phone, they both go to the FortiGate and say, hey, what's my IP address? FortiGate says, man, it ain't my job. Go to the BCC. So we have a separate client class built for the Yalink phones, separate than the ATAs of the AIR's modems. So they go out, grab an IP address from the BCC, and then they say, okay, I have my IP address. The ATAs, which is the phone piece of the cable modem, says, what's my config? So it'll grab a config file. So both the cable modem side and the ATA side grabs configs from the BCC and says, what's my configuration? Now the Airlink phones are a little different. The Airlink phones will say, FortiGate, what's my IP address? And FortiGate says, go to the BCC. Once they grab an IP address, those phones are programmed to say, I'm going to go to the SIP provisioning server. The SIP provisioning server, I'm going to throw another 7610 address at you. 7610.211.138. So once that phone, that Yowning phone, gets its IP address from the BCC, which is 7610.211.148, that phone hits this, then it says, okay, where's my config? It's going to come out and hit its config there. That's when it hits our Metaswitch provisioning server and says, okay, Meta, what is my configuration? That's when it pulls the soft key stuff it's supposed to.
Right.
The soft key stuff. Any changes that were made to it, and that typically happens. Most sites, I've been looking at traffic. Most sites does that. They automatically check in with provisioning at 2 a.m. across the board. If you look at our traffic statistics, it hits at 2 a.m. Most sites. Then you'll see a few come in like at 3 or 4 a.m. But that's so. At Canterbury, those two VLANs rely on the BCC to get their IP addresses. And if you notice, we made them so big. I mean that's a pretty big subnet. From 172, so Esco data, the usable is 172.18.0.1 through 172.18.3.254. I mean, that's a lot of IP addresses. And the reason we did that is because, one, we have a lot of equipment out there. We have 20 plus switches out there. We have CMTSs, we have open gears, we probably have 100 IP addresses there. Then we have business phones. How many business phones Canterbury got? 100 at least? 90, 96 or something like that. They got 96 business phones. Then you have all the ATA, or you have all the cable modems. We have, what, 500 cable modems out there? 400?
Yeah, there's like 360 residents, right?
There's 360 residents, and some of them have surfboards as well.
Right,
So that's
surfboards.
another IP address. So I mean, we kind of went big with this one because we're like, okay, man, we're going to have a lot of devices out there, and they're talking about expanding at some point too. So we our network planning process has to reflect that.
They're building a new building.
And that's another reason we did the voice the same way, because we're going to be if they're adding residents, they're going to have voice on it.
That's the better half of 1,000 addresses, correct?
I mean, yeah.
Like about 750-ish.
Yeah,
Plus.
I mean, so we've had instances. Bethany is one of those instances where we've had to add a second VLAN for voice traffic. I mean, we have VLAN 2 and VLAN 20 out there because we had to add a whole separate subnet in order.
They're crushing it.
Because they got so big, and I wasn't here from the planning part of Bethany, and
Yeah, that's like 700 residents.
yeah, that's 700. I mean, it's pretty big. And then they have how many?
Plus the business.
The business phones. I mean, they have upward 300 business phones. So I mean, we kind of shot ourselves in the foot on that one. So that's why we're trying to make bigger blocks, make it to where we have cushion, because all these communities, what are they looking to do? Expand. They have their existing infrastructure. We were talking about one the other day. They're looking at buying the shopping mall next to them so that they can, it's like, so these places are wanting to do nothing but expand, and we have to kind of have that in our hearts when we set these sites up. Video, it is what it is. I mean, video is the same way. So think of the BCC concept. You plug your cable modem or your Yowling phone in, and it has to go to our core to the BCC. Video is no different. It doesn't go to BCC though. It goes to our LANA, which is the IPTV DHCP server. So every set-top box, if that IP VPN's down, guess what? It ain't getting no IP address, and it ain't gonna have no video either. So that actually goes out, and all of the IPTV sites go out to one single LANA that's in our core. It goes out and says, hey, here's my MAC address. Give me an IP address, and then it will pull configurations files. So think of the LANA as the BCC for set-top boxes. It's essentially what it is. It'll grab firmware images and things like that.
I wonder what that did.
So this is where we get into their business part. This is kind of their business part as well. But workstations and point of sale. Typically in all of our deployments moving forward, VLAN 104 will be our residential VLAN. But this is where I kind of screwed the pooch on this one, because their point of sale systems were all essentially tagged for VLAN 104 already. The problem being is that when they were tied into their Cisco switches, they were doing VLAN translations. I didn't want to do that. I didn't want to do a VLAN translation for every single point of sale printer or point of sale workstation or whatever it may be. I mean, they got, I don't know, probably 30 or 40 of these devices sitting out there. So I said, okay, we're just going to make VLAN 104 our workstation / point of sale. And the reason I did workstation is because they have people in their business office who actually connect to these point of sale systems, and they see what they're like, what's being processed, and they have some kind of a management application that does that. So every single workstation at Canterbury Court resides on VLAN 104, and actually in that workstation you have like their network printers. So they have a couple the big Ricoh copiers sitting out there. They've got, some people have some desk printers and things like that. They all reside on that 104. And 104, yeah, I did make that /24. Okay, let's get on to the wireless, because Mitch
I have
posed
a
this
question about the workstation POS. Why would you not put the POSs on their own?
Because
they
they
have to integrate with the workstations, or how?
it was a request by the customer.
Okay, cool.
So, I mean, I went down the path of, I wanted to add a separate VLAN for point of sale.
Yeah.
But then, so here's another kicker within, this played a role in that, is that wirelessly with Ubiquiti, we can have up to 5 SSIDs until we have to build another container for it. Well, we were right at 5. And I said, well, Drew, can we split this and then do it this way? And he said that point of sale actually had to have their own wireless, but then, and it had to be a certain password, it had to be this, but then come to find out it didn't. So really we could have, and then at that point we were already integrated and,
You mean to tell me Drew didn't know he's talking?
So wireless. The reason I said, and Mitch posed this question earlier, why would we have a separate network for guests? Why would we have a separate network for wireless? The reason I did wireless the way that it is because they actually, so their building control system, they have people who carry around iPads and all this garbage, and they wanted a dedicated wireless to where we can restrict the traffic to their servers. They can, we can have certain, we do some MAC identification to allow certain things, but they have these tablets. It's like almost like an iPad that does their HVAC control stuff. They carry around a tablet, and if they're in a certain zone, they can actually, change the flow of it. So I made them their own wireless network for their business use. That's for business use. That's Canterbury Wireless. So that's supposed to be deemed as strictly business. Then I did guest, and they wanted a guest because they wanted a splash screen portal that says, "Welcome to Canterbury. This internet connection is monitored. Anything that you do is being recorded, which is not." And they kind of wanted to have that feel to it. That way we can actually restrict, because they actually do have a lot of guests that come in. When I was down there for a week, I was only there for a week, but there were so many people that were walking in that door that were like vendors. They have guests that people that come in and actually provide like companionship for certain residents. I met one lady that was there. Her job was to come in Monday, Wednesday, Friday in the morning for 3 hours and sit and play games with this lady, talk to her, have fun. That was her job. She was a healthcare companion. She was a registered like SDNA or CNA or something like that. But she literally came in and made sure that she was taking her medicine. And she said she was playing board games with her. It sounds like an awesome job to me. Walking in and be like, "Hey, taking your medicine? All right, you'll play some Skip-Bo." You'll play some dominoes or something.
Backgammon.
So that's what those they call them vendors, or they call them guests.
Yeah.
They come in. They have it's a 20 by 5 internet connection that's assigned with the guest. Don't see a whole lot of traffic. So on to EMR. EMR is actually with our nurse call application, and it's campus wide. Those phones travel all over the place. Security, actually the security team carries those devices as well. They go everywhere. They're all over the place. And I'm going to go into the wireless settings after this because we've made a lot of changes down there. Security. The reason they have their own security VLAN is because every door, most doors have a mag lock on it, and they have cameras. They have over 300 cameras on that campus. They have a security server.
They must have added some.
Oh,
I
they've
thought it was
added
280.
No, they have added a lot more since I've been down there. And so they have, I mean, they wanted a subnet strictly for that security stuff, and we do control stuff with that with Drew. Then on to resident. So resident is anything hanging off a cable modem, and then we have a resident Wi-Fi as well. So they have, you plug in your room, you get the same IP. If you plug into your room, your cable modem gets one of these IP addresses, then it's NATed behind it. So they get a 192.168. I think is it a 1 dot or a 0 dot? It's a 0 dot, I think. It's a 0 dot address, and then it's all NATed through that 10.66.7 address. Now, if you're on the residential Wi-Fi, you get a 10.66 address, but it goes out the same. It's on the same VLAN. You get applied the same rules. You get the same restrictions. It all lives on that 109. So now on to the wireless stuff. Everything, all of our Wi-Fi at Canterbury is 5G. We're not advertising the 2.4 anymore, with the exception of the EMR.